Alright, in this video I'm going to be reviewing and talking about the basics of a sequence. So very basic ideas behind a sequence. So first off, we should probably figure out what exactly is a sequence. So a sequence, here's an example. It's like 2, comma 4, comma 6, comma 8, goes on and on and on. Essentially what it is an ordered list of numbers. So it's an ordered list of numbers. So 2, 4, 6, 8, dot, 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 goes on and on and on. Where 2 would be the first term. So sometimes we call these n. So the n here would be 1. So this is the first term, this is the second term, third term, fourth term. There's an order there. So an ordered list of numbers like 2, 4, 6, 8. Now, when you see dot, dot, dot there, that means this is infinite, meaning this keeps continuing. So 2, 4, 6, 8, 10, 12, 14, 16, so on and so forth. If it looked like it would have ended, that would be called finite because it would end there. So we're going to write out the first 5 terms of the sequence. Given f of n equals n to the third plus 1. So if I need to write out the first 5 terms, if I want to know the first term, that would mean n is 1. So what I'm going to find is I'm going to figure out f of 1. Well, notice how I replace my n with 1. So over here on the right side, I'm going to replace my n with 1. So that's going to look like 1 to the third power plus 1. Well, this is the same as, 1 to the third power is 1 plus 1, so I get 2. So the first term in this sequence is 2. And then I'm just going to continue this trend. So nothing really changes a whole lot except instead of n being 1, I'm now on my second term, so n is now 2. So that's going to look like 2 to the third plus 1. Well, 2 to the third is 8. 8 plus 1 is 9. And then f of 3. So I'm going to have 3 to the third plus 1. So notice the changes there is as I go to my second, my third, all I'm doing is I'm changing n from 1 to 2 to 3. Not real big changes. A lot of it's the same. So 3 to the third plus 1 would be 27 plus 1, which is 28. Then I would find f to the 4, which is 4 to the third plus 1, which is 64 plus 1, 65. And f to the 5th would be 5 to the third plus 1, which is 125 plus 1. 126. So I kind of rushed through those last few just to understand all you're doing if you want to find the first 5 terms is start with n being 1, plug it in, figure out your answer. Then do n is 2, n is 3, n is 4, n is 5. So the first 5 terms of the sequence are 2, 9, 28, 65, 126. So that's going from the actual formula to figuring out the first 5 terms. Now what we're going to do is we're going to look at given the first 4 terms, find the next term, then write out a rule for the nth term. So we're given the terms, they want us to come up with this rule. And notice it comes in terms of n. So that's pretty important. So like on these, this is n is 1, 2, 3, 4. Now with these problems, there's no real trick to them. A lot of it is just having a sense of numbers and how they work. So you're trying to look for patterns there. So for example, I have a fraction here, fraction, 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 fraction. So my next term is probably going to be a fraction as well. So that's one pattern I notice. The other obvious pattern is I have 2, 2, 2, 2. So I'm probably going to have a 2 on the numerator for my next term. Then if I look at the bottom, I go 3, 6, 9, 12. So trying to look at the pattern there, 3, 6, 9, 12, I notice I'm increasing by 3 every single time. So if I go from 12, I'm going to have 15. So 2 over 15 is going to be the next term of my sequence. Now this is all fine, but what I want to come up with is I want to write a rule for the nth term. So I'm going to write some sort of formula like I had up above, that if I want to find, say, that 30th term, I can plug into the formula and figure it out. So looking at this, well, notice how I always have 2's on top. So when I'm coming up with my formula, I'm probably still going to have a 2 on top. So just trying to find patterns. So I'm always going to have a 2 on top. That works for all these. The bottom is going to be a little bit more difficult. So go 3, 6, 9, 12 to 15, and that would be my fifth term. What I would like to do is try and write something in terms of n. So I'm going to need somehow n involved. So how do I go from 1 to 3, 2 to 6, 3 to 9, 4 to 12, 5 to 15? Now some of you might see the pattern right away. So you can think of it that way. Look at your n terms. How do I get n to these numbers, 3, 6, 9, 12, 15? Another thing that can help you is, yes, we do increase by 3 every time. So there's probably going to be a 3 involved. So I think, how can I use 3 in these n's to get 3, 6, 9, 12, 15? Well, if I took 3 times 1, I get 3. 3 times 2, I get 6. 3 times 3, I get 9. 3 times 4, I get 12. 3 times 15, or 3 times 5, I get 15. So anytime I take 3 and multiply it by whatever n is, I get the denominator of my fraction. So if I look at this formula, I want to check and make sure it works for all of them. So in the first term, 2 divided by 3 times 1, yep. 2 divided by 3 times 2, yep. 2 divided by 3 times 3, so it works. So this is my next term, the 2 over 15, and my rule is 2 divided by 3n. And that was basics of a sequence.